Have you ever thought about how we're connected through the internet to every single part of the world? Although it seems simple, most of you will think it's just a case of connecting your phone or your laptop to the Wi-Fi, but truly, it's so much more than that. In fact, we have wireless connections at distributor ends. However, for the transmission, the whole world is connected through giant cables, most of which are underground and at the bottom of the sea. So welcome back guys to Let's Get Techy. As always, I'm your host Luke. In today's video, we're going to talk about how the world is connected through the internet, and specifically how the internet travels across oceans. So if you're curious enough to find out more, then stick right to this video and remember to subscribe to the channel if you haven't already. So getting back to the task at hand, the vast majority of anything that you see on the internet, including presumably this video, is transmitted to you from deep inside the Earth's ocean. In fact, nearly all of the data that is transmitted across international boundaries is done so by the means of a complex network of cables that are laid out on the seabed of the world's oceans. The ocean cable internet goes back more than a century. In 1886, for the first time, transatlantic cables were successfully laid down in the oceans. Despite the possibility of shark attacks, cables continue to be the technology of choice up to this very day. This is primarily due to the stability and dependability of cables rather than that of satellites and other means. By the end of the year 2021, there will be around 436 different submarine cables operating all around the globe. The total number of cables is always shifting since there's always new cables being installed and there are always older cables being removed for service and repairs. In the past, copper wire was used for internet cables. However, fiber optic technology is now used in today's submerged communication cables. At one end of the cable, there are lasers that fire at extremely high rates through tiny glass fibers to receptors located at the other end of the cable. For the purpose of protection, these glass fibers are encased in multiple layers of plastic and sometimes steel wiring as well. A cable's width during the majority of its travel across the ocean is typically compared to that of a garden hose. The filaments that convey light signals are incredibly thin, with a diameter that is about equivalent to that of a human hair. These fibers have several layers of insulation and protection surrounding them at all times. More layers of armouring are added to cables that are installed closer to the shore to make them safer. These wires extend all the way into the depths of the ocean. To prevent damage, the cables are located closer to the shore and buried beneath the seabed. This is the reason we don't notice wires near the beach. However, cables that are located further out in the ocean are laid directly on the sea floor, which is why they are often bitten by sharks. Of course, a great deal of caution is exercised to make sure that the cables travel the route that is least hazardous in order to avoid fault zones, fishing zones, anchoring places, and any other potential hazards. So if you're curious where these cables are, you can check TeleGeography's submarine cable map to find the location of these exact cables. Nearly all countries that have a coastline are connected by a submarine cable. To ensure a reliable connection, most countries actually have multiple cables. Traditionally, telecom firms have held these internet cables. These companies then create a partnership with any other parties who are interested in utilizing the cable. At the end of the 1990s, there was an increase in number of business-minded companies that built a lot of private cables and then sold the space on to the consumers. Both the consortium and the private cable models are still in use today. However, one of the most significant shifts that has taken place over the past several years is the types of business that are participating in the construction of these cables. Major investors in new cable infrastructure include content companies such as Google, Facebook, Microsoft, and Amazon as well. In recent years, the amount of capacity that has been added by the private network operators such as these content providers has exceeded that which has been developed by the past internet backbone operators. For these corporations, the acquisition of new submarine cables makes financial sense as they have more bandwidth and can therefore attract a larger audience. Regarding the cable faults, they often occur continuously. Each year, there are typically more than 100 errors in total. But why don't we hear much about these cable faults? Because the majority of companies that use cables employ a strategy known as safety in numbers, which involves spreading their network's capacity across multiple cables. This makes sure that even if one cable breaks, the company's network will still work normally with the help of other cables while the broken one is being fixed or repaired. In addition, 2/3 of all cable problems are results of accidental damage caused by things like fishing vessels and ships that drag their anchors. Earthquakes and other natural disasters, such as extreme weather events, also contribute to this damage. Components that are submerged in water have a lower risk of failing, and shark attacks are also extremely uncommon. In fact, they are more damaged by human activities as we just discussed. And apart from that, the cables have a minimum design life of 25 years. However, there is a possibility that these cables will continue to function far more than 25 years, but in practice, they are decommissioned much sooner due to their economic obsolescence. After that, they simply are unable to deliver the same amount of capacity as modern cables at a cost that is equivalent, and, as a result, it would be too expensive to maintain them in service. So that's why they're decommissioned. Even after a cable has been turned off, it may still be there on the sea floor. We'll never know. So who dragged them out there then? For that purpose, there are an increasing number of businesses that are acquiring the rights to the cables, pulling them up, and salvaging them for raw materials. After they are pulled out of the oceans, the wires that have been decommissioned are rerouted over alternative paths. In some cases, ships retrieve the retired cable from one place and then relay it along a new route. At the various landing stations, brand new terminal equipment has been installed. This strategy could be way cheaper to do things, especially for countries that don't need a lot of capacity and don't have a lot of money. Apart from that, many of these fiber cables, when they are cut off and laying on the seabed, are actually still a lot of help. Scientists use these cables for seismic activities to learn about the magnitude of earthquakes. Although they're cut off, they still radiate the signal, which is incredibly helpful for the scientists. And finally, let's actually talk about how the cables are installed on the seabed itself. Before they can be laid at sea, the cables need to be placed aboard a cable-lay vessel so that they can be transported. Some of these vessels have the capacity to carry up to 2,000 kilometers of cable at one time alone. Just loading the cable can take anywhere from 3 to 4 weeks, but once it's in place, it can be laid at a rate of approximately 200 kilometers per day, with the correct equipment, of course. After the cable has been loaded onto the vessel, it is then laid out along the shore until it reaches the edge of the water. The ship that is laying the cable approaches as close to the shore as it safely can without running aground, and then digging begins. Ships are used to draw a form of plough that simultaneously installs cables and drills a trench for its placement. If a cable runs over another cable or cannot be buried for some reason, it may be necessary to pick it up and reposition it. Undersea mountains, valleys, coral reefs, rocks, and fault lines are all taken into consideration while calculating the path that the ship will take across the ocean. This kind of preparation requires a significant amount of time and effort. The cables will ideally be placed in regions that limit the danger of damage from boat anchors and fishing trawlers. Sometimes two ships begin the procedure at two different sites, lay cable between until they meet, and then connect the two cables together to save time. It's actually quite genius. And that's it guys, that's the end of today's video on how the internet travels across the oceans. If you have any questions regarding today's topic or want to share something that is related, feel free to leave us a comment down below. And if you haven't already, hit that bell icon and subscribe to the channel. Thank you once again for taking the time to watch this video. I'll see you in the next one, and as always, have a wonderful day.